Okay, hi everyone. This is your first screencast of the 2018-19 school year. Maybe this is the first screencast ever, but in this screencast, I'm going to be deriving for you where this formula came from. Derivation, you are never going to be responsible for getting a derivation, but I think it's nice to see where they come from, okay? So we know for an arithmetic series, the summation of k terms is going to equal a sub 1, the first term, plus a sub 1 plus 1d, and then that's the second term, right? Third term is a sub 1 plus 2d, right? 2 of the constant is plus a sub 1 plus 3d. This is old news, right? This is the first term of an arithmetic series, the second term of an arithmetic series, the third term of an arithmetic series, and the fourth term. And we notice that, if you look at the fourth term here of the series, this is the first term plus 3 of the constant differences. So if we want the sum of the first k terms, you know that your very last term of this series is going to be a sub 1 plus how many d's? Well, what do you think? Let's see. The very last term of the summation of k terms is going to be a sub 1 plus k minus 1 d's, okay? Because the series is arithmetic. So again, like the third term of the series here is a sub 1 plus 2 d's, right? So the number of d's you add is always 1 less than the term position, okay? First term, second term, third term, fourth term, kth term. This is the kth partial sum. Now, I'm going to do this. This is where I'm going to do something kind of wild. I am going to express the same partial sum this way. I'm going to write out this series backwards. You ready? So the very last term is going to be a sub k. That's the last term, right? All right. Plus the second to last term is going to be the last term, subtracting d, a sub k minus d. Everyone okay? All right. Plus the second to last term is going to be the last term minus 2 d's plus, okay, the last term, a sub k minus 3 d's. So I'm going backwards, you see? So this is the series written from the first term to the kth term. This is the series of k terms written from the kth term going all the way back to the first term, which is going to be a sub k minus how many d's? That's right, k minus 1 d's. And boys and girls, when I do derivations, a derivation is just a way that I show you where something comes from, okay? Whether you can follow every single step, I'm not overly concerned with it, but for those of you who find this kind of stuff pretty cool, then, I think it's worth seeing. Now, I'm going to take these two equations and guess what I'm going to do. I'm going to add these two equations. When you add two equations, what you do is add the left-hand side of the equations and you add the right-hand side of the equation. You know there's going to be an equal sign here. S sub k plus S sub k, what does it equal? 2S sub k's. Okay? Now we're going to go ahead and add these terms, add these terms, and add these terms. Let's look right here. A sub 1 plus A sub k, well, that just gives me A sub 1 plus A sub k, right? That's these two. Okay, let's do the parenthesis. Now, plus, all right, what is this plus this? I don't know why this yellow isn't there. I think I kind of got a little overexcited with my highlight. There we go. Okay, what is a sub 1 plus d plus a sub k minus d. So you see how the plus and minus d's cancel out? Yes, you do. I know you do. So when you add these two, we also get a sub 1 plus k. Plus, all right, let's add now these two, right? Let's add these two. Let's add these two. When I add, what happens? Positive 2d minus 2d, those add up to another a sub 1 plus k. I think you notice something. Every pairing here that I add, right, you're going to end up with a sub 1 plus a sub k. Let's look at the last term here. If I added these, right, this expression here, all of that when I add is going to cancel with all of this. So even back here at the end, I'm going to have plus dot 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 plus a sub 1 plus k. Now I'm going to ask you, how many a sub 1 plus k, whoops, what? I lost my a sub k right here. Oh my goodness. Again, what happened to my these should be a sub k's. Good grief, how embarrassing. A sub 1 plus a sub k, right? I don't know why. I think I said it and I just didn't write it. My question to you is, how many groupings of a sub 1 plus a sub k's are there? Well, how many terms are here that are being added up? There are k of these. So at the end of the day, there are k a sub 1 plus a sub k's, or there are k a sub 1 plus a sub k's. This equals 2s sub k. And the whole point here was to derive the formula for s sub k. I'm going to now look at both sides here, divide both sides by 2, right? Cancels. At the end of the day, s sub k equals this. This is nothing different than k divided by 2 times a1 plus a sub k. And there you have it. This is the formula that I gave you in class, and I said, eat it. And only a few of you said, well, what's in it? That's where it comes from, okay? The second part of this screencast, and boys and girls, I just say this, for screencasts, you want to treat them as if they were class notes. But I told you this is a derivation. Maybe some of you want to copy this derivation down and make little notes of what I said. Maybe you want to show, your brother or sister over dinner tonight when you're eating your hot dogs. But really, you don't need to copy down a derivation. There will be some screencasts that will be actual full lessons, okay? Now I'm going to switch gears here. Naturally, you're probably wondering this question. Is a S sub k formula shortcut for what kind of series? For what's the other one? Oh yes, for geometric series. Like, is there a shortcut, or do I have to do the whole, plugging and chugging on my calculator? Okay, is there a shortcut for geometric series S sub k? And the answer is yes, there is. Here it is. Okay, here it is. If your series is geometric, your eighth partial sum for a geometric series equals, okay, going to equal, oh my goodness, I have to do the derivation. Let's do the derivation, okay, because I don't remember it right now off the top of my head. Let's do the derivation. We know geometric series equals a sub 1 plus a sub 1 times r plus a sub 1 r, how many times? The second, plus a sub 1 times r cubed plus a sub 1 times r to the fourth plus da, 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 da. And if we're adding up k terms, right, our very last term is going to be, let's see if the pattern is the same as arithmetic series. It is, right? The number of times you multiply by r is 1 less than the position. So the second term here is a sub 1 times r to the first. The third time here is a sub 1 times r to the second. So my very last term is going to be a sub 1 times r to the how many times? Not k, but k minus 1. Okay, this derivation is a little bit different. Here's what I'm going to do. I'm going to multiply both sides of this equation, which I'm allowed to do. I'm going to multiply both sides of the equation by r. Okay, multiply both sides by r. And the left-hand side becomes r times s sub k to the k, or the k partial summation of the first k terms of its geometric tree. Now, when I multiplied r by the right-hand side, because I have terms here, or I have things that are being added or subtracted, I have to use a distributive property. And a has to be multiplied by all of these terms. So a sub 1 becomes a sub 1 times r. The second term becomes plus a sub 1 times r squared plus a sub 1 times r cubed, okay, plus a sub 1 times r to the fourth, plus all the way through, I'm not going to write this one, that would be a sub 1 times r to the fifth, plus, now listen, this was a sub 1 times r to the k minus 1. When I multiply this term by r, when I distribute, this becomes a sub 1 times r to the k, right? Very good. And now what I'm going to do is this. Okay, I'm going to do something here. I have my original equation that's in yellow. That was the original one. I have this green equation that was the result of taking my original equation and multiplying everything times r. What I'm going to do is take yellow equation, and then I'm going to subtract this entire equation. Okay? Right? And when I subtract, right, and again, to subtract, there's going to be the equal sign here. All right, s sub k minus r times s sub k becomes s sub k minus r times s sub k. All right, now take a look here. I'm going to subtract all of these terms here, right? Minus all of the terms here. Now this is the part where some of you may not be able to follow me. I'm gonna just, let me do this, watch this. I'm gonna put a little kind of, just gonna put a little hold around this guy, all right? When I say a sub 1 minus r minus a sub 1 minus r, that gives me 0. A sub 1 r squared minus a sub 1, because it's a minus sign by the way, a sub 1 minus a sub 1 r squared, this becomes 0. A sub 1 minus r cubed minus a sub 1 r, okay, 0. 0. All right. Oh my. This term, by the way, it's right here, right? Because this term, when I subtract, okay, everything zeroes out except this guy is left hanging and this guy is left hanging, right? When I subtract the two equations. So on the right-hand side, I am left with just a sub 1 minus a sub 1 times r to the k. All right? Now I'm going to do some factoring, okay? Left-hand side, I'm going to factor out s sub k, which is undistributing. And if I factor out s sub k, what am I left with? Yes, 1 minus r. Equals, factor out a sub 1. A sub 1. Am I left with? 1 minus r to the k, right? That was kind of undistributing or factoring. Now I'm going to divide both sides by 1 minus r. S sub k equals, oh here it is, a sub 1, the first term, all times 1 minus r to the k, all divided by 1 minus r. And there is your k partial sum, only for what kind of a series, everyone? Just geometric. So, for example, the sum of the first k terms of a geometric series is the first term all of it multiplied by 1 minus r raised to the power of k, all divided by 1 minus r. Okay, so there you have it. You now have your kth partial sum formula for a geometric series and your kth partial formula for an arithmetic series. And not only that, you have the derivation. All right, so this is for geometric series. Okay, for geometric series, kth partial sums. All right, so make sure you have that down there. All right, when I see you tomorrow, we will work with this formula a bit, and we will pull everything together with respect to sequences and series. Have a good evening. Goodbye.